All right, so this is the same document that we used in our last session, and it still has quite a lot to cover, so we may not still be done with it today, but let's see what we have for today. So let me push it to where we are reached. So we are looking at the concept of the pixel and how an image is created by the computer. Now that's an area that you covered at computer graphics, but it is very helpful also in this particular unit. So much of what we are doing last week was almost a review of some of the work that you did with computer graphics, and the basic processing of the image takes the concept of the bitmaps. Now, you notice that the word bitmap has the bit part. It's about bits. It's about creating a space or something is being developed by a combination of bits, and that is what we did. We talked about the concept of the bit depth, bit depth. So the bit depth, we said, is a coding that is used by a system, and the issue is to say how many bits are we going to use to represent or to code a point of image, which we also call the pixel. So a point of image. So the images are simply many. Of course, the better word to use is the dots. So if you think of the dots, and sometimes as I give this analogy, when the people are younger as children, growing up and learning things, one of the ways that is used in education as an activity for children is to be taught to join the dots. You join the dots, and when you join the dots, normally in that kind of an activity, then after you join the dots, it creates something. So it maybe it's meant to develop into an image of a lion, or an image of a house, or an image of a tree, but you are given just dots, and then you are told to join the dots. Now, although that's not exactly what we do here, but it is very much similar, that you get many dots, and the many dots make the image. So an image is simply a group of dots. I mean, an electronic image. The way the image is created by the computer and then finally displayed on our screen is simply many points, or many dots, or many pixels. It's just many pixels that finally make up the image. And so that's where we get this word bitmap. And so this is a basic image, but then the images could be converted to other formats. We have other formats, but this is the basic way that the image is created. Well, that is a recap of some of the things that we said last week. We also talked about now the coding. So the coding is when it comes out the coding, we say now how many bits do we want to use to represent or to code a pixel, or to code a dot. Now remember, you have many dots, but each of them, what is a bit? How many bits do you use? Of course, that goes by a system. Once you decide, this system should use 16 bits, then any dot that represent an image will be 16 bits. And so maybe that's where we should start in terms of thinking. So how big is an image? But before we go to considering the sizes of images, which we also call graphics. So in computer terminology, images are also called graphics. but graphics are more, is like more a representative of the still images, the images that are not in motion, the images that are like a drawing, you draw something on paper. Of course, in that case, it's just an analogy. We are not drawing on paper, we are drawing electronically, like the way you go to either Microsoft Word, and then you draw a circle, or you draw a rectangle, draw a triangle, or you have to draw a proper shape, maybe a shape of a car or a house, whatever you may draw. So when you are doing that drawing, of course, normally it is just a still image. So most of the time we use the word graphic when we are describing a still image. But image, of course, the word image can be general, both those that are just still, but also the ones which we see like in a movie, a video, they are moving. You see something is just moving normally like it does in a real life. Then that's also an image. But now, of course, it is in motion. Well, so we are we also, as I said, we have different other types of formats. Now, the basic one, now let me just go back again and emphasize that, with the bitmaps. So the bitmaps is a basic way that an image is made. But sometimes we don't always use the bitmaps, the basic image that is developed by the system. Instead, we also have other forms of images. So in most cases, these other images are a conversion of the bitmap. And so we have these other formats, other image formats. So for example, the JPEG. Normally people say JPEG, but you can see what it means here, Joint Photographic Expert Group. So that's initially, of course, that was just a group that, is a group of developers who came up with a certain type or a certain format or a certain way of representing an image in a different format other than the bitmap. So they of course they borrowed, they use that to name as the name of the group of developers, but now we normally just shorten it as JPEG. But in most cases we don't use now we have what is called what is this file extension. We have file extension. You say for like when you create a file with Microsoft Word, it has a file extension docx. So now so you write the name of your file, then .docx to indicate that normally it indicates the kind of application or the software used to develop that document. And so we do have these file extensions. And so for the bitmap, we have BMP as a file extension. So for JPEG images or images that are created in the format of JPEG, normally we don't use the whole of JPEG to label them. We normally just use a JPG as a file extension. So if you see an image that ends with .jpg, then that is an image that is in the format of the JPEG. So those are so that's one of the other formats of images. The other formats of images. So what are the other formats? Let me just remind us, keep checking with the audio and reminding me from time to time whether it is still clear, so that we can be sure that we are continuing to communicate. So the other formats, so we have JPEG, we have also GIF. GIF, which again is indicated here, what it means, graphics interchange format. So, and again, so it says it's normally used for diagrams, buttons, etc. that have a small number of colors. It is also suitable for simple animation because it supports interlaced images. So this GIF, normally when you use a GIF, it requires that you are not you are not having an image that requires very many colors. In other words, if you want to take an image, let's say it's with your camera, you want to take an image, and you want to take an image, and you want that image to be stored as a GIF image, then you should make sure that it does not have a lot of colors, because some of the colors will get lost. That's what this text is telling us. It does not support a situation where the image has so many colors. Some of the colors might get lost, and of course, so these are different formats. Of course, again, you have to choose them depending on the type of image, what the end product of your image. What when it comes to colors, this is mainly about the colors. So the type of how you want your colors to come out, that may determine which format you'd like your image to be stored in. So we have GIF, which we are reminded that it is normally used for diagrams, buttons, etc. that have a small number of colors. And then it is also suitable for simple animation. Now, we talk about now animation by definition would say is a moving image. When you, not image, but it is when you add motion to something, not just image, but anything displayed to the computer can be done animation. When you add motion, so you make it move around. It's not just a static, static on your screen. It is moving around. Then that is animation, and so of course, especially when it comes to images, then it can help with the animation of images, and because it says it supports interlaced images. Now, interlaced images is mainly about making images appear on the screen. It's like it does not show every detail immediately. It shows it keeps on. It starts with the less details, and then it continues to improve the details until the full details of the image is finally displayed on your screen. That's what we're calling interlacing. So it first of all displays just a few details of the image, and then continues to add more and more and more, and finally display every detail of the image. And so that's GIF images. And then we have also PNG images. So PNG images, it says is almost equal to GIF, except that it doesn't. Now that needs to be corrected, that it doesn't support the animation format, so it is almost equal to GIF. So it means that also this one may not support a lot of colors, and so we have to consider when we are maybe when we want to store our images and decide what format. So what format do we want our image to be stored in? So depending on how many details, how much detailed you want your image to be captured, then we have to decide on the formats carefully. So the bitmap, of course, is, as it says in another slide here, which I'm going back just to find the description there. It was giving some details. I think that I can't trace the specific slide quickly enough, but it was saying if you want an image that has a lot, is very detailed. Any speck of a color that is in a certain image, and when it has many colors, then the best form or format you should store your image is in form of a bitmap, or it should be a bitmap image. It was the document calls it photo, the one which is a photorealistic image. In other words, it captures almost every color that is in an image by the time when you want to change it. So, when you want to store it as an electronic image, and you are trying to capture that image. So when you are capturing it, it's best if you capture the image and store it as a bitmap. So it's here. This particular slide I'm now in is one which was giving us that information. So bitmaps are best for photorealistic images or complex drawings requiring fine detail. So if you want to see an image almost the way it was in its natural environment, so if you want to take a snap of somebody, and you want it to come out almost every detail that is a part of that particular person, then the best form is to take the image and store it as a bitmap. But that comes at a cost as far as the amount of space required to store your image is concerned, which we'll be discussing in a short while. So the bitmaps, and then the other forms. So the other forms are more what these other forms, as I said, normally I'll first of all you get the bitmap and then you change to these other formats. So normally that's what happens. Initially you create the bitmap, and then it is processed to any of the other images. But that does not require to say, let me have a bitmap image, then I see it, and then I convert. No, it can be converted at the same time. So when the image is being captured, it will be captured as a bitmap, but whatever you are using to capture that image may already have a system within it which automatically converts the image to the form that it normally is, that particular device. Like if it's a digital camera, so it will take a bitmap, but by the time it stores the image, it will already have done the conversion, because bitmaps can take a lot of space. But if you want a bitmap, of course, then you can set your system to store the image as bitmap, and then you can maybe convert it later. Maybe we want it to be bitmap at that particular moment. All right, so the different types of formats for images. So that's what we have been looking at. But let's also say now, how do you create these images? Of course, we are saying bitmaps because, as I said initially, all images are bitmaps and then converted. Now, bitmaps. So we have a discussion here. It says, how do you create bitmaps? So, or how do you get images generally? And we have different ways of getting the images. Of course, most of these, as it says, these are bitmaps. So you can you can get images from what is called the clip art galleries. Now, this is normally part of the system. It is part of the system. It's just like in Microsoft Word, for example, you have a function to color your text or to underline. But of course, you also have a system within such a application for drawing images and things like that. But together with that, there are inbuilt images within Microsoft Word and other systems where you just open and you see the images and just do copy and paste. So that's what is called a clip gallery. So that's one of the areas where you can get images. But you can also use a software that you can draw directly. You draw your own images. We have quite a number of such softwares. Or you can use a camera. Now, when you say capture here, is mainly about things like using camera and just take a photo, for example, you capture. But you can also get images and then edit them. For example, you can do a copy and paste of an image from the internet, for example, and then you edit that and you make some changes here and there, depending on the interest at that time. But the other way of creating or getting some images is by doing scanning. I think this is also something that is familiar. For example, you took a photo, and then this photo is now on a, of course, those olden days, I think we can talk about that. Maybe the photo is there. Yes, it was put on a frame. It's on paper. It's not electronic yet. But then you decide now this image I would like it to keep a copy, digitally. So what you do, you just take that photo, take it to a scanner, scan the image, and there it is. It is created into an image that can be stored digitally or electronically. So scanning is another way of obtaining an image. So those are the various forms, and I will not go through the text describing all these forms. I've already just given an overview. Please read down these slides that are here that they describe all those various ways of creating your image. I know there's one which, okay, capturing and editing. I think there's only part, maybe I may pinpoint something here. There is also another way of what we are calling capture, capturing an image. So of course you can use a camera or anything that is similar, but you can also capture an image from the computer screen. So the computer screen we can also capture. So when you display an image on the computer, you can capture that image and then of course do some editing to it probably, but maybe just to store it as it is. For example, suppose maybe you like to get an image of maybe the president of US. You want to have an image that maybe you might want to put it in one of your documents which you are maybe doing some research. So you can just go through the internet, get an image where an image of the president of US shows up, and then you do what is called the print screen process. Normally there is a command called print screen, and it's the one which you can use to capture images that are showing on your screen. Of course, that can take anything that is screen. It's not just an image. So anything on your screen can be captured by using this print screen process. In the computers using Windows, they say it is there is normally a button. There's a button called print screen for computers that use the Windows operating system. You just press that button. Of course, it is not always really full, but you can easily locate it and see that this is the button that does the capture of the screen as it is on Windows computers. And then here it's also saying how we can do the same process in Mac computers. So it says you press 3 buttons, actually four buttons together, Command, Control, Shift, and the number 4. So if you do that, then you capture the screen as it is. Whatever you are seeing on the screen is captured. Of course, there's an image. Of course, when it is now stored, it will be stored like any other image. And that's why you can say it is still an image, But of course, in terms of sometimes it may be just text, but you want to take whatever is showing on your screen as an image, and so that is also another way of doing this capturing. Just like you take a photo, so this is another way. You have an image, something on your screen, and you capture it. Okay, so those are the various ways that we can develop bitmap images in this case. And as I said, of course, there is also scanning. But as I said, is that the other images, of course, are also done in a similar way. I mean, you first of all get the bitmap, but then you can convert it either to a JPEG or to a PNG or to a GIF. You do the conversion, and then you get those other images. Now, some of those terminologies and the concepts of formats of images will come to them at some point later to look at something called compression, doing a compression process, because sometimes some images can be too big for certain purposes, and so we sometimes do the conversions because of the purpose that we have at a particular moment in time. For example, when you want to send an image through the internet, bitmap images are so big, so huge, that it can take so long to download. And so sometimes we do the conversion to the other images, other formats, because they may reduce size of the image in some way, which we'll discuss later. So the image is reduced in size so that it becomes a smaller in its size for easier transmission through the internet. So before we go to look at vector drone images, I want to take us back to the concept of this particular the bitmaps, and we discuss about the issue about sizes. I don't know whether we have that discussion somewhere later. I'm just going through the slide again, and no, I think that discussion may not be there, so I better introduce it at this point. So how can you decide on the expected size of an image? The expected size of an image, and it is based on the issue of the bit depth. So the bit depth, and because a bitmap normally takes a rectangular shaping of the comprise the way the image is created by your pixels. The pixels take a rectangular type of a block, and then the image is created within that block, and even the way it is going to be shaped, because of course not everything is rectangular, but the way you see the image will still be based on a rectangular block of pixels, and different pixels will be activated differently to finally form the image. But essentially, the whole block of rectangle will be part of the size. The actual image will not take the rectangle, but finally, your image will be equal to the number of pixels within the rectangle block of pixels around your image. So first of all, it is the issue of the bit depth. So the bit depth, we said, is the number of bits that you use for your coding. So you choose how many bits do you want to use to code your dots. How many how many bits do you want to use to code your pixels? And so you can decide that you will use one bit, like in this case, of course, that can only give you only 2 colors. So that's a problem. You cannot show more than 2 colors. And normally this one is used for black and white. Just If all you want is a black and a white, then you can just use a 1 bit to code to be your coding. Say your coding system could be based on 1 bit for just 1 bit for a color, which means that you're only able to show 2 colors, because the one bit will show 1 color, the other bit can only show 1 other color, and so you have a maximum of 2 colors that are possible. So that would therefore be like a black and white system. But if you want your system to be able to show more than 2 colors, then you have to go to higher levels of bits per pixel. And we discussed this last time, so I don't want to go back to that. And so we're saying, and this time I'm going to go back to what we call the whiteboard. So we can look at this concept of the size. So how can you calculate how big the size of your image might be? How big you can calculate ahead how big your image can be for the sake of deciding on space. So it is where we ask, do we have that amount of space ourselves? All right, so let's look at that briefly. Now, this class, I don't want it to last for long today. I wanted to allow you time to look at the forum, as well as this session has also been added a quiz. So I want to allow you sufficient time to look at the forum as well as the quiz. You look at those and answer, do a reply to the forum as well as to the quiz. So let me remove the share. So we go to the whiteboard. We just do a short discussion on that. We'll actually not also complete this one. We'll pick it up in our next session. But let me introduce it. So we're going to call it calculating the size of an image. So let me put a short sub heading here for this purpose. So this is calculating sorry, I think I missed the calculate. Size. For now, we call it bitmap because, as we said, we normally start with bitmap, and then we convert them to other sizes. I mean, to other formats. Yes, the audio is still working on, or so let me still get a confirmation. I can see Bernard was raising a concern. Are we better now with the audio? So as I continue, please just let us confirm that. Okay, yeah, okay. Thank you. Godfrey is confirming that it was some point earlier on, but now we are okay. All right, so how do you calculate the size of the bitmap? Now, for now, I've just, as I said, we'll continue. We look at this more clearly in our next session. So if you know the number of, so how many bits? So the first question is, how many bits or how many pixels does your image have? So how many pixels? All right, so how many pixels? Well, let me just write that one also. So you say number of pixels in the image. Sorry, I think it's the text is too big. Sorry, I will not put the heading again because I want us to close in a short while. All right, so number of pixels. So let me reduce. I think my text is too big, but I also don't want to make it too big, too small. So you need to know number of pixels in image. So we have to think about that. So how many pixels make our image? Let's maybe put a figure here. Let's assume that our image is, let's say 2000. Because normally the pixels are very many. Because the pixels are very small, by the time they make an image, they are very many. It's just like the concept of the microorganisms, bacteria and all that, and this corona that is disturbing us, the viruses, very small, very minute. So by the time you actually have an image, you need already very many pixels. So this is just for the sake of discussion. So suppose your image is made up of 2000 pixels. Then those 2000 pixels, then the next question you have to ask yourself is how many bits are used for the pixel? So this is a bit depth. So what is bit depth? And the bit depth is number of bits per pixel. Now, sometimes that is also referred to as the resolution. We'll talk about that later, about the concept of resolution. Sometimes also called points per pixel, PP, something like points per pixel is like a triple P. But anyway, bits per pixel. So what are the number of bits per pixel? And of course, you can see now that one is an obvious calculation, isn't it? Because from here now it's just to say, so what is the total number of pixels? Now, because bits brings us to the size. You see, the bits is what gives us the bytes. So if it's a word like Kenya, so we describe it in terms of the bytes, but it is so if you have stored that word in your computer, let's say on your hard disk, how much space is it using in your hard disk? So you say how many bytes of space it is using. But initially it is the bits. It is the bits that become the bytes. And of course, the conversion that we use nowadays, and of course, it was introduced originally, is that 1 byte is 8 bits. So that's the conversion that we normally use. So we can say now, so first of all, therefore, what are the total number of bits? So we go on now from there and say, so therefore, total number of bits in this image. So total number of bytes. Bits. First of all, is the bits in this image equals, of course, is just a multiplication there. So bits. Okay, sorry. We should have assumed a size. I think I went too fast. So I'll be forced to go back here. Now here we should have assumed some bit depth. So let's assume our bit depth this time is 24. 24 is very popular. So and we call it bits per pixel. So let's assume that is our bit depth. All right. So if that's the case, then the size of our image, in this case, first of all, you calculate the number of bits. So how many? What are the total number of bits in this image? So of course, it's just a direct multiplication problem here. 2,000 times 24. So we have 22,000 pixels making our image, and each pixel has a coding of 24 bits. And therefore, so that's multiplication is what? 48,000 bits. So the total, so it's of course 2,000 multiplied by 24, which is a simple number there. So that's 48,000 bits. Remember, these are bits. Okay, now we sorry, the wrong. So 48,000 bits. Now it's very important that you are able to pick up. We don't lose track of your whatever you are dealing with. Whether are you dealing with the bits, are you dealing with the bytes? So at this point, we are still dealing with the bits. Then we now convert these bits to bytes. So the conversion is that 8 bits make 1 byte. And so we need to divide this now by 8. Make them bytes. Because, of course, you don't express size in bits. We go to the bytes, to the kilobytes, the megabytes, etc. So we need to have, first of all, to convert this one to the unit of measuring memory or memory space. And so now we go to convert it to bytes. Now convert these to bytes. By dividing by 8. And then now the size this of course now takes us towards now coming up with the size of our image in terms of bytes and kilobytes and megabytes etc. So if you do that, then this will be equal to what? So if you divide by 8, now I'm not show that here because this system cannot help me to do that in a good way. But of course, these are simple arithmetic again. Well, I think that would be a good point of interaction at the chat. So why don't you give me your value? What is 14,000 divided by 8? Let me see a number of you doing that at the chat. Okay, in the meantime, right, several of you are saying 6,000 bytes. Yes. Okay, keep writing as I check something. I'm getting to be back in a short while. Yes, keep adding more. Everybody, even if you have already agreed, write yours as well. All right. This is like the case where you say that just because that others have eaten, you should not say you not eat. Keep eating. So write yours as well. Even if others have written, write yours as well. Let's have a text that says that this has come from so and so. Keep writing that. But yes, I agree. But you can even say you agree with somebody else who wrote something there above. You agree with those that so and so. You just put your own number. Keep writing that. That's very important. Remember, with these online classes, it's very important that something shows that you in what is going on. As part of just a recording that you actually are active in the whole process of our online interactions. So it helps even if you repeat what somebody else has done. Of course, I want to believe that you not repeat if it's wrong, but if it's right, keep writing the same. And sometimes you agree with so and so. But anyway, yes, I agree also that 6,000 should be what should be our value here. So we can continue, but if you have not added yours, you can also continue to add. So when you convert to bytes, then our conversion gives us 6,000 bytes. So that will be the size of our image. Of course, that is also, when we do that conversion, then now the size of our image, therefore, is 6,000 bytes. So we can say size of our image. So size of the image is 6,000 bytes. Sorry, I think I put my box is a little small. I will try to expand it later. So, but 6,000 bytes, maybe that may not be the best way to write it. So, 6,000 is already a kilobyte. Now, kilobyte would be a better expression. So, we try always to move to the next better unit to use. And so, instead of saying 6,000 bytes, I think it's better to say 6,000 kilobytes. Now, normally, although 1 kilobyte is not exactly 1,000 bytes. A kilobyte is actually expressed as 1024 bytes. 1 kilobyte is 1024 bytes. But we assume the numbers are above the 1,000. So we just talk in terms of thousands. And so we take, for calculation purposes, we normally take 1 kilobyte to be 1,000 bytes. And so we convert this one to kilobytes. And we say that which is equals to divide by 1,000, 6 kilobytes, KB. All right, KB. And I think there I can also just remind us about the symbols representing different measurements. Normally we use a small b, the small b for bits, and the capital B for bytes. So that when you see these, sometimes when this information is written in using in short forms, sometimes it's not very clear whether somebody is talking about bytes or whether somebody is talking about bits. So normally that's how it goes. The capital B normally for bytes and small b normally for bits. So our image therefore would be 6 KB. So if you are storing it on our disk or on your flash disk, then it is going to be consuming that amount of space. Space equal to 6 kilobytes. It's an image that whose size is 6 kilobytes. It's an image that whose size is 6 kilobytes. Of course, that's a very small size, but remember this was just for demonstration. Normally, images become very big very quickly because, as we said, remember the pixels are so small. So by the time they create an image, you use a lot of them. It's not like writing text. Now, text does not require a lot of bits to create, and so text normally does not use. Even a lot of text, you will find that it is not using a lot of space. But when it comes to an image, it becomes big within a very short time. Within just a small image showing on your screen can become quite big because it is made up of pixels. It is pixels that make the image. So by the time you have enough to show the image that you are showing, you would have used a lot. And each of those pixels has a number of bits that it carries with it. And so by the time you complete your image, it is already becoming very big. So images become very big very fast. And so we'll be looking at this. So this was just introducing us to the concept of how to calculate the size of an image. But we'll look at this also in the next session as we conclude this topic on images. We'll be able to also revisit these, how to calculate the size of an image given certain parameters. Maybe are given the bit depth, maybe are given the size in certain ways. Actually, next time we'll be looking at if you are given the size. Now here we just says, in other words, if you are given the dimensions. Normally we talk in terms of blocks of, rectangular blocks of pixels, because that's how actually the bitmap is made. So now here, we already just said that our image, the whole image. So in this case, we did not calculate from dimensions. We just have the number of pixels given, that the whole image is made up of 2000 pixels. And then from there, we also given the what is called the bit depth, which is essentially the number of bits per pixel, the number of bits per pixel. And so from there, now we are able to find out. Therefore, in terms of the amount of space that we need for storing this image electronically, either in our hard disk or even just displaying it on our screen. Of course, what is displayed on the screen is in the RAM. It is first of all stored in the RAM before it is displayed on your screen. So it is using your computer memory when it is displaying. So when it is using your computer memory, how much space of your computer memory is it using? So that's what the kind of calculation that we are trying to do here. Well, students, I want to end my presentation there for today. I'm making it a bit short, but I want you the remaining time to go to the discussion forum, and also there is also a quiz that is set there within this area. Now, all this is at the space on our portal. It is written topic 3 session 2. So within that space, you should be able to find the quiz and also the discussion forum. Make sure that before you log off, you handle that, reply to the discussion forum, and also reply to the quiz. So the quiz is also just a part of the activity. It's not the card. It is not the assignment. It's just part of the class activities. But of course, finally, all these do add up to your grading or your grades at the end of the semester. So even if it's not the assignment, it's not the card, all these activities add up to the grading of your unit in this online approach. And so that's why even when we get a chance to do a discussion in class and we use the chat, make sure that you should always try to add something even at the chat so that it can show up in the system that you are participating in the activities of the class. But otherwise for today, I'll end it there for my presentation, but I'm still around here. I'll still be just at the meeting room. And if you have a question, you can put it in the chat and I'll be checking if there is any question. And of course, I'll keep your mic available just in case. You could also raise a question using the mic. At least for the next 15 minutes, I should be able to respond to any comment or question or point of clarification that you may want to raise. But as for my presentation, I will end it there. And thank you for listening.
Classmates, Mama. I think of what I'm thinking. Last year, job. Video.
Yes, Godfrey, any question?
Not really. I'm good personally. Mi nimeelewa.
All right, that's good.
Alafu nimeona swali huku hivi inauliza an electronic system uses a bit depth of 16 bits. How many different colors is it capable of displaying? How do I answer that?
All right, ask again.
An electronic system uses a bit depth of 16 bits.
Yes,
How many different colors is it capable of displaying? Oh, I get it. Nimeelewa.
you get it, eh?
Yeah.
All right, all right. That's good. We actually discussed that one last in our last session, eh?
Yeah.
Yeah, we say something about it.
While.